The central message for this module, module number 5, is going to be centered around protocols. So essentially we first outline what protocols really are, and then we'll talk in some detail about what is possibly the most important protocol, which is the transmission control protocol operating over IP networks. Now, a protocol is actually just simply a set of rules that define how systems communicate, right? So that's the one line statement definition of what a protocol really is. So these are essentially the rules or standards that define the syntax, the semantics, and synchronization of communication, and also possible error recovery methods. So protocols may be implemented by hardware or by software or by a combination of both. The Internet Protocol Suite is the set of communication protocols used on the Internet. So it is commonly known as TCP/IP. TCP stands for Transmission Control Protocol, and IP, as mentioned earlier, is just the Internet Protocol. Now, TCP/IP provides end-to-end data communication, specifying how data should be packetized, addressed, transmitted, routed, and received. So that one sentence itself should make it very clear to you that TCP is extremely important for data communication over IP networks. The TCP/IP protocol suite uses a 4-layer model. So at the protocol layer, you've got the application protocols layer, and these are protocols that are specific to certain applications. So for example, for our purposes, HTTP, which we described earlier, is the most common. So other examples are FTP, RTSP, SMTP, and so on and so forth. At the TCP layer, TCP essentially directs packets to a specific application on a computer using a port number. It's important to note that TCP actually guarantees delivery of your message. So other examples of transport protocols apart from TCP is UDP, which is User Datagram Protocol. At the IP layer, IP directs packets to a specific computer using an IP address. And at the hardware layer, this converts binary packet data to network signals and back. So for example, you've got Ethernet or 3G or 2G or 4G or modem for phone lines, etc. Now, getting on to protocol layering, to ease design, protocols are structured using a layering scheme as a basis. So instead of using a single universal protocol to handle all transmission tasks, a set of cooperating protocols fitting the layering scheme are used. So each level of the stack performs a particular function and communicates with the levels above and below it. So all HTTP information is put inside a TCP packet. All TCP information is put inside an IP packet. And all IP information is converted to appropriate signals that get sent down the wire. Now, given the importance of TCP/IP, we'd like to talk about it in a little bit more detail. So the message essentially starts at the top of the protocol stack on your computer and works its way downward. If the message to be sent is long, each stack layer that the message passes through may break the message up into smaller chunks of data. On the internet, these chunks of data are known as packets. The packets go through the application layer and continue to the TCP layer. So each packet is assigned a port number. Now ports will be explained later, but for now it would suffice to say that many programs may be using the TCP/IP stack and sending messages. But we need to know which program on the destination computer needs to receive the message because it will be listening on a specific port. So after going through the TCP layer, the packets proceed to the IP layer, and this is where each packet receives its destination address, for example 5.6.7.8. And now that our message packets have a port number and an IP address, they are ready to be sent over the internet. So the hardware layer takes care of turning our packets into the alphabetic text of our message into electronic signals and then transmitting them. On the other end of the phone line, your ISP, your internet service provider, actually has a direct connection to the internet. So the ISP's router examines the destination address in each packet and determines where to send it. Now, more often than not, the packet's next stop is usually another router. And we'll talk about routers and internet infrastructure later on. So eventually the packets reach computer 5.6.7.8, and here the packets start at the bottom of the destination computer's TCP/IP stack and then work upwards. So as the packets go upwards through the stack, all routing data that the sending computer's stack added, such as IP address and port number, is stripped from the packets. And when the data reaches the top of the stack, the packets have been reassembled into their original form, Hello Computer 5.6.7.8. So in this module, we introduced you to the idea of protocols, and we paid a little bit more attention to the most important protocol out there, which is the TCP protocol, and we explained that in a little bit more detail.